All right. So far we talked about various geometric notion, various geometric figures, various geometric shapes, and those shapes were what we call plane shape. We talk about triangle. It's a plane figure because you can construct a triangle in a plane. By plane we mean a flat surface. Now we want to extend our idea about geometry into object or figures. They are in space. But in space means we are thinking things to be in space. This, you can think this pen to be a line in a space. If I put this pen on the board, this will be a line on, this is line on a plane. Now we are thinking a lines or any geometric shape in the space. Well, one of the example of very nice example of geometric figures in space, they are called plane. If you think of a room, you have one wall vertical, another, your roof is horizontal. So your one plane, the vertical plane is meeting the horizontal plane. Well, as I said, a plane means just a piece of paper. This is a plane, this is another plane. So these are a geometric figure in the space. You need a three-dimensional space to study them. Okay, so plane are the simplest type of geometric figure in the space, and you should realize when we have two planes, two planes might meet or might be parallel. And in fact, if the two plane meets, you will see a line over there. They will cut in a line. So the meeting point of they will not meet at a point. The two planes will meet at a line. So if this vertical plane is meeting with horizontal plane, here is a line. Okay. So that means that line is line in a space. So now we are thinking of lines in the space. This is a line in the space, this is another line in the space. If we have two lines in the space, they might intersect like this, they might be parallel like this. So, and you know, if you have a line in a space that might be parallel to a plane, by saying a line is a parallel to a plane, we mean the line will never intersect the plane regardless of how long we extend it. For example, right now, well, you don't see the floor here. This line, this line, the plane, the line described by my pen will never meet the floor regardless of how far we go. So I can say this line described by the pen is parallel to the floor. And by saying a line is perpendicular to a plane, we mean this situation. This is the plane, this is the line, let's say. Now this line is perpendicular to the plane. In fact, by saying this line is perpendicular to the plane, what I mean is this line is perpendicular to every line you can construct in this plane. So a line perpendicular to the plane, perpendicular to every line in the plane. Line parallel to the plane means it will never intersect the plane. Now we talked about closed regions, closed polygons, and closed curves, like we talked about circle. Now we will extend that idea of closed plane region into closed geometric shape in the space, and they are called simple. We have something called simple closed surface. By simple closed surface, we mean a surface with one interior and no hole in it. For example, a soccer ball is a simple closed surface, well, without the hole. Well, when you are playing soccer ball, you know, the hole is, you know, tight anyway. So for example, you see this is a intersection of two planes. This is not a closed surface. So this is not a simple closed surface because it's open. Now you look at this, This is a closed surface, there is no hole in it. This is also a closed surface. They have an interior and they have no hole. Now, if the closed surface, simple closed surface is made of polygonal region, if the boundaries are polygons, by polygon they could be triangles, they could be square, they could be pentagon, hexagon, heptagon or what not. If the surface of a closed, if the boundary of a closed surface is made of polygons, we call them polyhedrons. This is an example of polyhedrons whose surface are triangles. Looks like maybe not equilateral triangles, but no, not the equilateral triangles, but the surface are triangles. Here is a triangle, another triangle, another triangle. You are constructing a closed surface using triangles. Well, in this example, triangles, it could be any polygons, it could be heptagon, it could be hexagon, it could be square or quadrilateral. Once we have a polyhedron, you see we have something called faces. The faces means this triangle is the face, each triangle, in this case they are called the faces, and edges means they will intersect the two face. Edges is the intersections of the faces. They are lines, by the way. Edges are the lines wherever the two face will intersect, and vertices are the corners. Corners when the edges meet. So, when we have a polyhedron, we have faces, the faces will meet, those meeting lines are called edges, and again several edges will meet at different places. The meeting point of the edges are called vertices. So, in this example, these triangles are the faces, these are the faces, and this is an edge, and this is a vertex, this is also a vertex. There are bunch of vertices, bunch of edges and bunch of faces in the polyhedron we have. Now, as in the case of the plane figures, in case of object in space or three-dimensional object, let us say, we have the concept of concave and convex object. We will say a closed region is convex if every line segment joining any 2 points in it is contained inside or on the boundary. For example, let us think of this polyhedron whose faces seems to be triangular. Take any 2 point, imagine, think of any 2 point inside the this surface, inside this surface, and think of connecting the 2 points. The line connecting any 2 point inside it will remain either inside the inside this region or on the boundary. So, this is called convex. Now, you see this, if you take a point somewhere here inside and you take a point somewhere here, I am taking 2 interior points. If you connect them, you see this portion is outside. It is not completely, this line is not completely inside the region or on the boundary of the region. A portion of the line joining these 2 points, this point and this point, is outside of the region. So, it is not a convex region. Well, then we extend our knowledge from polyhedron to regular polyhedron. As we already know, polyhedron means their faces are polygons. If the polygons of the polyhedron are regular polygons means equilateral triangle, squares, regular pentagon, regular hexagons. if the faces are regular polygon, we call the polyhedron to be regular polygon, and this is a regular polyhedron whose faces are squares. Sometimes this kind of regular polyhedron is called the cube. If you think of the cube, the faces are all squares. They are regular squares. And we can have octahedron, so many different dodecahedron, tetrahedron. When we say octahedron, you know, the faces are looks like triangular, here also triangular, and here we have the faces looks like 1, 2, 3, 4, 5 pentagons. Okay. Now, the next some special class of, now we will talk about a special class of polyhedron. One of the special class of polyhedron is called, they are called pyramids. For pyramids, base means this is the example of pyramid, this is the base. The base could be any polygon. In this case it looks like rectangular base, and the sides are triangle. If the sides are triangle, regardless of what polygon we have on the base, that kind of tetrahedron is called pyramid. Well, we can have different names for pyramid. Their names are based on the shape of their base. The base could be any polygon. So, if we have if the base is a rectangle, then we call it a rectangular pyramid. If the base is a hexagonal, we call hexagonal pyramid. If the base is heptagon, we call heptagonal pyramid. And if the base is this is decagon, so we call it decagonal pyramid. So base could be anything. The lateral sides has to be triangle, and depending on what is the shape of the base, we have different names for different pyramids. Prism are almost similar to pyramid, except they will have two bases. Remember, for pyramids we have only one base. Now prisma are almost similar to pyramids, except they will have two bases. One of them we call upper base. This is the upper base, and we have a lower base here, and and the two bases are congruent. They are same. We already know what do we mean by congruent. The two bases are same, and they get the name again based on the shape of the base. So here the base is looks like 1, 2, 3, 4, 5. So it should be pentagonal prism. Well, this is a rectangular slab, so rectangular prism. And cube is an example of prism also, because you may think the top of the cube is one of the base, the bottom of the cube is one of the base, and the lateral sides are other polygons. Hexagonal prism and parallelepiped is also a prism. Then we go to next concept called cones and cylinders. Of course, we know cones, right, ice cream cones, and of course we know cylinder also. Our soda cans are, most of them are cylinder. Well, they are counterparts of the pyramids and the prisma. Cones looks exactly almost the same as pyramid, except the lateral surface is not polygon. It's a curved surface. It's not a polygon. And the base of a cone is circular. In case of pyramid, the base could be any polygon and the lateral sides are triangle, but in case of cone, the base is a circular one and the lateral side is a curved one. It's not polygon. The same thing with the cylinder. We have a circular base, another circular base, so two bases like in case of prism, and the lateral surface is a curved one. It's not polygon. The next geometric shape we see in space is spheres. Soccer ball, and well, the shape of our earth. They are spheres, and well, it will have a center inside, and this is what the sphere will look like, and it will be hard to draw a curve in a surface in a space. It will be difficult for me to draw it here. So this is the center, and by radius we mean join the center to any point on the surface. That's the radius. Well, if we join 2 points on the surface of the sphere, and if the line joining the 2 points goes through the center, we join 1 point here to another point here, and if the line goes to the center of the sphere, that line is called the diameter. And we have the concept of latitude and the longitude. So latitudes are these circles. You are cutting a circular piece like this. They are latitude. You might cut circular piece like that. They are longitudes. Okay, so here is the equator of the sphere. Here is the center of the sphere. We say the latitude and longitude, we name them by degrees. So 20 degree from the equator, and here is 40 degrees from the equator, and there is 80 degrees, 60 degree, and so on. The same thing goes for longitude as well. Now, when we have a sphere, if we project the sphere into some other objects, we get maps. There are bunch of different types method of projecting. If we project a sphere onto a cylinder like this, that's called cylindrical map. If we project a sphere, we have a sphere, we have the globe, and if we project it on the floor, on the plane, floor means the plane. If we project the sphere onto a plane, then that's another way of getting the map. And another way of getting a map is put the sphere inside a cone and project the sphere onto the cone. We get conic map as well. Well, and when we talk about object in space, one of the concept that comes quite frequently in geometry is the concept of symmetry. An object is said to be symmetric if it looks the same on both sides. For example, if we think of this square and cut this square like this half and this half will look the same. They are congruent. So we say this square is symmetric about this line. Similarly, if we cut the square along the line, along this line, along a diagonal, the upper rectangle, upper triangle and the lower triangle will look the same. So we say the square is symmetric about this line also. We have already seen for a square there are two types of symmetry, one cut across this, one cut across the diagonal. And you might say, well, we could have done cutting it across this diagonal or across this. So there are 4 different lines of symmetry for a square. Well, if this is a shape given to us, if we cut this shape in the middle like this line will be dividing the shape into 2 exactly same looking shapes, that means congruent shapes. So this line is the line of the symmetry, and in this case you can see here is a line of symmetry and here is a line of symmetry. Well, sometimes some shapes will show rotational symmetry. If we rotate it by certain degree, we are going to get the same thing again. For example, let's think of 1, 2, 3, 4, 5. There is a pentagon, and we already know the interior angle in a pentagon is 108 degrees. If we rotate a pentagon around its center, the center, this point will be rotating around this point, and this point is called center of rotation. So keeping that point as a center of rotation, if we rotate the pentagon by 108 degree, we're going to get the same thing. We're going to get the same thing. That means pentagon has a rotation symmetry, and the angle of rotation for the symmetry is 108 degree, and the center of rotation is the meeting point of this triangular region of the pentagon. Well, so we looked at several geometric shape in the space, and we talked about various different types of symmetries. Let me know if you have question. Have a nice day. Thank you.